Solving a system of equations with two variables. So today we're going to look at a system of two equations in two variables. If we have one equation in one variable, we can solve it. If we have two equations in two variables, we can solve it. If we have three equations in three variables, we can solve it. If we have two equations in three variables, that's not solvable. So keep in mind, the number of equations and number of variables have to be same, then we can solve for each of the variable. To solve a system of two equations in two variables, we do need, we have two methods. Elimination method. In this method, the goal is to make coefficients of either one of the variables same but opposite. Most commonly, we have equations in x and y variables. So either we want the number in front of x is same but opposite, or the numbers in front of y is same but opposite. To make this happen, sometimes we have to multiply one of the equation with a particular number. In some cases, we might have to multiply both the equations with a particular number. The second method is substitution method. The goal in this case is to isolate any one variable from one of the equations and substitute it into other equation and solve that equation. Let's go ahead and look at the examples. And to use substitution method, it's easier if we already have a variable with one in the front. For example, in this case, we have one in the front. So in front of the x, there's a 1. So that means in this case, substitution is easy. We can go ahead and use the method of substitution, or we can also use the method of elimination. So I'll go ahead and do both the methods here. I'm going to try the substitution method and substitution method first, and I label the equations as A and B. So from equation A, it's easier to get the x by itself. So get x by itself. So whatever variable has 1 as a coefficient, that variable is easy to get by itself. So from A, we get x by itself. So we can say x is equal to negative 11 plus 7y, or 7y minus 11. Addition is commutative. It doesn't matter in which order we write the terms. Once we have the x alone from one equation, we're going to plug x equals 7y minus 11 into the second equation. So 5 times 7y minus 11 plus 2y equals negative 18. Let's go ahead and solve it now. So we'll have to distribute 35y minus 55 plus 2y equals negative 18. So that is 37y equals negative 18 plus 55. 37y equals 55 minus 18, and that is equal to 37. That gives me y equals 1. Once we know y is equal to 1, once we have found one variable, we can actually plug the y equals 1 into first equation or second equation, or even in the relationship that we found earlier between x and y to find the x value. So I'm going to plug it into the relationship that we found earlier. We know x is equal to 7y minus 11. So I'm going to go ahead and replace the y by 1. X equals 7 minus 11. So 7 minus 11, that turns out to be negative 4. So my answer here, solution set, is negative 4, comma 1. X coordinate go first, y coordinate goes later, negative 4, comma 1. And we can check our solution by plugging. I'm going to do a quick mental check. I'm going to replace x by negative 4 in the first equation, and y by 1 in the first equation. Negative 4 minus 7 is equal to negative 11, so that works out okay. Same thing in the second one. I'm going to replace x by negative 4. That's negative 20 plus 2, which is negative 18. So it works okay. I have checked my answer. I have peace of mind. If you did the math correctly, your answer should always work out. Now, I'm going to use elimination method for the same problem to show you the comparison, but it's always, if you're not told in a problem a particular method to be used, then you can pick the method that's easier for a problem. For this problem, I think the substitution was easier, but elimination is also not very complicated. So I'm going to rewrite the problem. And I'll use a different color. I'm going to use method of elimination. To use method of elimination, I need to multiply any one of the variables. I need to have the coefficients of any variable same but opposite. So I'm going to multiply the first equation with -5. So my first equation becomes -5x plus 35y equals +55. The second equation remains the same. The benefit of doing this is now I have the coefficients in front of x is same but opposite. I'm going to go ahead and add the two equations. So 35y plus 2y is 37y. 55 take away 18 is 37. We get y equals 1. Now we can replace y equals 1 in the first equation or in the second equation. I'm going to go ahead in the first equation. X minus 7 times 1 equals -11. X equals -11 plus 7 equals -4. X equals -4. So again, we got the same solution. We should get the same solution either way. So we could have a one solution for a system of equations. If we were to solve it graphically, that means the two lines I have, they meet at this point. We could have no solution for two linear equations. That would be the case where the two lines are parallel. We could have infinitely many solutions where the two lines are overlapping if we were thinking about graphical method. But if we were using the method of substitution or elimination, in case of one solution problems, we will end up with a particular value of x variable and particular value for the y variable. In the case of no solution, I will end up with a statement that is never true. For example, 5 equals 0, 3 equals 9, something that's never true. In case of infinitely many possible solutions, I will end up with a system. I will end up with a equation which is always true, which is a true statement, which is an identity, and that would be the case where we have infinitely many solutions. Let's check out this example. Number 2 looks like either method would work here, and for this one, I will go ahead and use substitution. So my equation A and B, from A, get x by itself. So from A, if I'm trying to get x by itself, x comes out to be 2 plus y. So if that's the case, now plug x equals 2 plus y into the second equation. So 2 times 2 plus y. Now we are left with a single equation in one variable, and that's the goal, because if we have one equation in one variable, we can go ahead and solve it for that variable. Let's distribute. So that's 4 plus 2y plus 3y equals 9. 4 plus 5y equals 9. 5y equals 9, take away 4 is 5. Y comes out to be 1. If y is 1, we can plug that y equals 1 in here. X comes out to be 2 plus 1, which is 3. So my coordinate pair that works here is 3, 1, and I did use the substitution method here. In the next example, it's not easy for me to get either x or y itself by itself in any of these, because all of the x's and y's have a coefficient other than 1. So if I do try to isolate the x or y, I will most likely have fractions involved, and I want to avoid them. So what we're going to do is we are going to multiply the first equation on both sides with a -2. And the benefit of doing that is going to be I will have a new equation where one of the variables, x, will have same but opposite coefficients, or opposite coefficients, same absolute value of the coefficients. So I get -8x minus plus 6y, because we're multiplying with -2, equals -22. And the second equation, we're not going to touch or do anything with, because we already, by multiplying the first equation with -2, it solved the purpose of making the numbers in front of one of the variables same but opposite. Get rid of these. 10y equals -10. Y comes out to be -1. Now, to figure out the x value, we can replace y by -1 into the first equation or the second equation. So I'm going to go ahead and do that in the first equation. 4x equals 11, take away 3. 4x equals 8, x turns out to be 2. So my solution set here is 2 comma negative 1. See another example. Sorry, I have two number 3's. Let's call it number 4. Yeah? Yes. Okay, so let's see. We can use the method of substitution here. We can isolate the x by itself from the first equation. I'm going to go ahead and use the method of elimination because I think that's faster for me, but it's a personal preference. Both methods are about the same amount of work in this case. So I'm going to multiply the first equation with negative 3 to have the coefficients of x variables same but opposite. And let's see what happens when I do that. So negative 3x minus 12y equals negative 24. And I'm going to leave the second equation as it is because I wanted to make the numbers in front of x's same but opposite. Now let's see what happens. This is a kind of crazy problem because I am able to cancel the x's when I add the equations. 3x minus 3x is 0, 12y minus 12y is 0. So I have 0 on the left-hand side and negative 22 on the right-hand side. And this is never true. We know that. So this is a case where there is no solution to this problem. There's no values of the variable x and y that I can plug in here, and that will make both my equations true. So the solution we find, a particular value for x and y that we find, those two numbers satisfy both the equations. If you want to check your solution, you should plug it into both the equations to make sure it works for both the equations. If you did the math correctly, it should work for both the equations. Next example, looks like I don't want to use the substitution method here because I don't have any variable with the coefficient 1, so I'll go ahead and try to make the numbers in front of x's same but opposite. In order for me to do that, I need to multiply the first equation with the 3, second equation with the 2, because that way the numbers in front of x would be 6 and negative 6. The first equation becomes 6x minus 18y equals 30, and negative 6x plus 18y equals negative 30. Let's see what happens now. 6x minus 6x is 0. Negative 18y plus 18y is 0. 30 minus 30 is 0. And 0 equals 0 is a true statement, and this is always true. So that means this equation has infinitely many solutions. There's infinite many possible solutions. What does that mean? That means we can choose any x and any y, and that would make this not any x and any y. Actually, these are going to be, so if we go ahead and graph these, they're going to be lines that will be overlapping. So all the points on those lines will be the solutions. So 2x minus 3y, the x-intercept is positive 5. The y-intercept will be like negative 1 point something. So if we graph, this is how the lines are going to look like. And the second line will be overlapping here. All the points on these two lines are the same line. All these points will be the solutions to this system of equations. In the next video, we'll learn how to solve a system of 3 equations and 3 variables.